So what we're going to do next is a little bit of algebraic voodoo, okay? No sorcery or anything like that, just some voodoo. So here's the equations that we have so far. We got v equals v naught plus at, distance equals 1/2 v plus v naught time, okay? Remember, this one is not on your equation sheet, okay? It's not there. So if that's one that you want to have in your quiver of equations, when you get the test on Friday, hey, write that down. V plus v naught over 2 times time, okay? Or it's pretty simple to remember. It's just the average velocity times time, whatever works for you. But the reason that I go through this, number one, is handy to have. Number two is going to form the basis of the next equation. So here's my question. Connor S., do you think I could take this whole thing, v naught plus at, and substitute that into that other equation?
I don't know. Yes.
I could. Why? This is an easy question. Do not make this difficult.
I'm making it difficult. You put me
Good one.
Go with that. They equal?
Oh, finally.
They equal.
So,
Why is worse?
there's an equal sign, right? So these two things are interchangeable. They're equal. Right?
Yeah.
Okay. That's why I said, you're making this difficult. Don't. Okay? So here's what I'm going to do. I'm going to take this whole thing and put that into there. So now distance equals 1/2 v naught plus at plus v naught times time. All I did was a simple substitution because there's an equality sign. Okay? It's nothing radical. Now here's the story. Can I combine anything inside those parentheses?
Yes, you can recommend the initial velocity.
Yes, I can. So in this case, 2v naught or not 2v naught. In this case, I 2v naught. Now this is where we're going to do this without a net. Living on the edge. So I want to distribute the time, and at the same time, distribute the 1/2. Okay? I'm going to do a double distribution. Charles, are you up to the challenge?
I guess.
What am I going to get?
V naught t plus 1/2 at squared.
Winner, winner, chicken dinner. Okay? So this is this third equation, or the second equation that's on your sheet. So what's on your sheet, you have x equaling x naught plus vx naught t plus 1/2 ax t squared. Okay? That's what's on your sheet. Wow, that was aggressive. Now, 99% of the time, your initial position is just going to be 0 and you don't have to worry about it. Okay? Literally. The only time this is going to be significant is if you're like standing on top of a building and you throw a ball and then it falls all the way down to the ground. Okay? Otherwise, you just assume that x naught is 0 and there's nothing to worry about. So unless I explicitly tell you that you're starting at a point other than 0, you just assume that you don't have to worry about the x naught part of this. Now again, all this is reinforcing is the idea that x naught and acceleration is either going to happen in the x direction what's gonna happen in the y direction? Nary the two shall meet, okay? Nary the two shall meet, okay? So if I throw this ball up in the air, the only acceleration it's going to have is going to experience due to gravity. If I roll it across the ground, then it's going to experience horizontal acceleration. Okay? That's the reason that they put the x's on there. So functionally, out of this big equation, that's the one that we're going to use most often. Okay? Distance equals 1/2 at squared plus v naught time. Okay? Don't worry about writing out all of that stuff unless you're like, oh, Mr. Burkamp, I live to write out variables. Okay, fine, you can. It's not going to matter. Okay, so here's how this would play out. So let's say that you're going to have the carrot car, and we're going to let the initial velocity of the car be 0. Now, I'm not going to explicitly tell you in the problem that V naught is going to equal to 0. What I'm going to tell you in the problem,
It's not moving.
yeah, the car starts from rest, okay? So unless I explicitly tell you, hey, the car is moving at 5 meters per second, or the car is thrown off of a building at 10 meters per second, the Incredible Hulk throws the car at 10 meters per second. Unless I tell you that, you just assume the car starts at rest, okay? So don't make it complicated. If I want anything other than 0, I have to specify what that is. Okay, car is going to start at rest, it's a 0. So the car is going to travel for 20 meters, and then we're going to time it, and we're going to say that that took
5 seconds.
4 seconds. Okay? I'm going to pick 4 because the math is going to work out a little bit easier. Okay? So, here's how this would play out. We would go out in the parking lot, and we would take Sydney's car and we would have it at rest. Okay? And we're going to say, Sydney, punch it. Bam. Okay? And we're going to go out there and we're going to have a mark at 20 meters. And we're going to time how long it takes for her to travel those 20 meters. And then from there, we're going to try and calculate the acceleration. Okay? So we got 0, 20 meters, start, 1, 2, 3, boom, stop. There we go. Now, if you go to the V, well, don't like that one. The V naught, dat. Okay? What's my initial velocity? 0. Okay? Now, do I worry about my final velocity in this problem?
No.
No.
It's not part of the story. Okay? So, I don't worry about that. Not part of the story. Now, what else do you know? I know my time is
4 seconds.
4 seconds. That's horrible 4. And then my acceleration is what I don't know, and my distance is
20 meters.
20 meters. Okay? So literally, I'm telling you, if you come in and ask for help, it's like, Burkamp, I have no idea how to do number 5. Here's the first thing I'm going to ask you. Have you identified what the variables are? And if you haven't done that, I'm not going to help you. And I'm not doing that to be a jerk. But if you don't know what they are, then you're dead in the water. Okay? Now, if you say, Burkamp, I can't even figure out what the variables are. Cool, I can help you with that. But if you haven't figured out the information, trying to solve the equation isn't going to do any good. Now, even though we don't have to, what would this look like if you drew it on a velocity time graph? Mitchell, what would that look like on a velocity time graph?
A straight line,
Horizontal, sloping,
sloping,
where would it start?
at 0,
It's going to start here, then what's it going to do?
go up.
Something like this.
Yep.
So we have a time out here of 4 seconds. Now, how does the 20 meters be a part of that velocity time graph story?
Area of the triangle.
Yeah, that's the area of the triangle. That's that 20 meters. So could I do this? Could I take 20 meters and divide that by 4 seconds and go, well, the car is going 5 meters per second?
No.
Yeah. No.
No, bad. Don't do that. Why?
Because that's the distance velocity time.
Yes, it is not moving at a constant velocity. Do not take 20 meters and divide it by 4 seconds. Go, oh, it's moving at 5 meters per second. I will lose my physics mind if you do that. Okay? And then I'm going to have to write very sarcastic things on your paper, which I hate doing. Now, what's the sign of my acceleration going to be based upon this graph? Positive, because straight upward sloping line, right? Okay? So I know the area, I know the time, we're off to the races. Now at this point, we're going to use this distance equals 1/2 AT squared plus V naught time. Now, in this situation, my initial velocity is 0. And I don't want you to think, oh, your initial velocity is always going to be 0. No, in this situation it is. If your initial velocity is 0, what we do a lot is that you can draw an arrow. Are we leaving?
Yeah, we're going back to my cell phone.
That early?
We get out at 2:35, don't we?
Thought we got it at 2:40.
Oh, I'm off by 5 minutes, my bad.
Yeah, let's say now. I even know
I'm not leaving.
Well, we start at 35, it just
Yeah,
got
yeah.
lit.
Okay.
they hate us.
Are we good? Wait, why are you leaving so early? Like,
It's really.
is the lecture that bad? Rude. Okay. I like how you try and make it. I'll sit there and look innocent, and that'll make it work. Okay. So when you draw this, this is the international sign for this part of the equation drops out. Okay? That's all that's showing you. We don't have to worry about this part of the equation. Now, solve the equation first. Okay? You were not a freshman in an Algebra 1 class. Put in the numbers and then solve it. No! You're running with the big dogs. Solve the equation first. Connor A, I need that equation solved for acceleration and I hate fractions. What are you going to do?
Multiply by 2, divided by times squared.
So I'm going to have 2D over. Now, Mr. Etheridge, can you look at that and do dimensional analysis and tell me that I'm good or bad in terms of the units?
I can't.
There goes more gray hair. Luke, what's distance going to be in?
Meters,
What's time going to be in?
seconds.
Is that going to get squared?
Yeah, because, oh.
Oh. No, don't fist pump him on that. That is not fist pump worthy. If he got it the first time, okay, maybe nuts. This is not fist pump worthy. What do you get?
2 meters on the second spread.
Is that what acceleration's measured in? So I'm going to take 2 times 20 meters divided by 4 seconds squared. Cool with that? Do you get units of acceleration, Mr. Etheridge? You get meters per
Yes.
second squared. Now, here's what you're going to do wrong, and you tell me that you won't, and you lie. You're going to forget to square time. See it happen. The most common mistake that's made with this. So you take 2 times 40 divided by 16. You're going to get some acceleration. Okay, now we're done. We'll stop here. So if May Southie people need to head out, you can head out.
Maybe like 10.
No, you don't.
What? Don't look at the lanyard. The lanyard doesn't mean anything.
Or the shirt.
Or